So let's see, this is 6.5 that we're talking about today. So we want to prove So we want to know if we have a parallelogram, how can we tell if it is a rectangle or a rhombus? That's what we're going to figure out. Oh, and I need to open up this thing.
So I can need extra paper. Just
we'll do a couple of examples at the end, so you probably need another sheet. Go. All right, so let me grab this picture here. Don't want to do that. Do that. All right, so let's talk about how we decide if we have a parallelogram. How do we decide if it is a rectangle? So our first category there says if one angle of a parallelogram is a right angle, then the parallelogram is a rectangle. And we could mark any angle on our shape. All we need is one. So I could say if angle A, angle B, angle C, or angle D is a right angle. All we need is one. And right angle means what? 90 degrees, just so we remember. And the reason this works is if we know this is a parallelogram, what do we know about opposite angles of a parallelogram? They're congruent. So if this is a 90-degree angle, that would have to be a 90-degree angle. What do we know about consecutive angles in a parallelogram? Supplementary. So if this is 90, that one has to be 90 in order for them to add up to 180. So all of them have to be 90. So that's one way we can tell if we have a rectangle. We have a parallelogram with one right angle. All right, the next one we call the house builder theorem, and I'll talk about that in just a second. If the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. Diagonals, where do we draw the diagonals?
Like A to D.
A to D, across from corner to corner. Like so. There are my diagonals. And if we were writing this out, we would say AD, segment AD, congruent to segment BC. If the diagonals are congruent, then our parallelogram is a rectangle. And the reason we call it the house builder theorem is we have evidence, and we see with different cultures where they didn't have a lot of tools and measuring, like tape measures, that kind of thing. In order to make sure that a foundation was rectangular, they would use a rope or some kind of thing to make sure that the diagonals were the same length. And if the diagonals were the same length, they would know that their foundation was rectangular. They would know they weren't going to be out of square on their foundation, as long as they made sure that the diagonals were congruent. History of math, right.
Hey, did you bring yourself a journal with that?
I didn't. So you guys weren't here yesterday to remind me.
What about Joe? Technically Friday.
It's not Friday. So
It's not Friday, dude.
We're on math shirt.
It's not Friday. I have to have a routine.
math shirt in your
Dude, that's only Friday.
just in case.
Just in case. Just in case I spill coffee on it or something.
Yeah.
All right. Questions on this part of the graphic organizer? Okay, let's talk about rhombuses next. So let me grab those pictures. There we go. So now we're starting with a parallelogram. On the second side of the graphic organizer, we're always starting with a parallelogram. Now we want to decide how can we figure out if we have a rhombus. So the first one tells us if one pair of adjacent sides of a parallelogram is congruent, then the parallelogram is a rhombus. Adjacent, what do we mean by adjacent? Next to each other. So all we need is one pair of the adjacent sides to be congruent. And I could make it any pair of sides that are next to each other. So I just picked those two. So I can say segment AC congruent to segment CD. And the reason this works is kind of like we talked about with the 90-degree angle for rectangles. If this is a parallelogram, what do we know about opposite sides? They're congruent. So this would be congruent to this. Opposite sides, congruent. So all four would have to be exactly the same length, and that would make it a rhombus. All right, we're good there.
Hi, I walked them out, but I'll just somebody else again.
All right, so the next one, if the diagonals of a parallelogram bisect the angles, then the parallelogram is a rhombus. So the diagonals, just draw those in. And since they're bisecting the angles, what are they doing to the angles? Cutting them in half. So if I were to mark this on my figure, that would make those two angles the same. And it would make these the same. And there's lots of ways I could write out that those angles are being bisected. I'm not going to write out all the angles that are congruent, but I could say that AD bisects angle A and angle D, and BC, segment BC, bisects angle B and angle C. So the diagonals are bisecting those angles. Oops. All right, we good there? Last one, very last one on our graphic organizer. If the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. Perpendicular means 90 degrees. So let's draw in our diagonals. Now this isn't necessarily a perfect rhombus, so it won't necessarily look like it, but we're getting to the part of the book, we're part of geometry where we have to go by what the information tells us, not by what it looks like. So that would mean that this angle is a 90-degree angle. And we could say segment AD perpendicular to segment BC. And that guarantees us that our parallelogram is going to be a rhombus. All right, questions there. So like we talked about the other day, often figuring out that we have a parallelogram or that we have a rhombus or we have a rectangle isn't 100% of the problem. It's what we need to figure out in order to figure out the rest of the problem. And all of these things that we have on our graphic organizer are going to help us do that. So what I want to do next is just look at a couple of examples of using these ideas, and then we'll be done. All right. So for these next two, I want to know, is this shape a rhombus, a rectangle, or a square? So we'll draw a shape with some information, and I want you to tell me if it's a rhombus, a rectangle, or a square. All right, so there's our information. We want to know, is this a rhombus, a rectangle, or a square? So what piece do we have information about there? We have the length, the segments, which are the whats of the shape? The diagonal. What do we know about the diagonals?
They're equal.
They're congruent. So the diagonals are congruent. What does that tell us? The rectangle. What would we need to know that this was another kind of shape? We need to know angles or lengths of sides. Because this could be a square, right? To be a square, what would need to be true for it to be a square? All the sides would have to be the same. But we don't know about the lengths of the sides. All we know is it's a rectangle. I tried to draw it so it kind of maybe looked like a square. But we don't know the lengths of the sides, so we don't know that it's a square. All right, questions there? All right, let me draw another one. Same question, rectangle, rhombus, or square. Here we go. And I need to say one thing. We're starting out with parallelograms. So these are parallelograms. So we want to figure out how we can be more precise. So what about this one? Rhombus, because
They're perpendicular to each other.
diagonals are perpendicular. So that makes it a rhombus. Could it be a square? We need more information. What would we need to know for it to be a square?
What are the angle degrees or
We need to know the angles, right? It doesn't look like it, but if I said this angle is 90 degrees,
the rectangle?
then it would be a rectangle, and because the diagonals are perpendicular, it's a rhombus. So what shape's a rectangle and a rhombus? Square. Then it would be a square. All right. Last example. So this is going to be a parallelogram. So I'm going to put my arrow down here. And for this one, I want to say what the value of x makes it a rhombus. So what value of x would make that a rhombus? How would we do it? What do we need to? We would set equal to 90, because this is the angle where the diagonals intersect. In order for it to be a rhombus, the diagonals have to intersect at a right angle. So we'd say 6x minus 6 equals 90, and solve for x. So plus 6x equals 96, divided by 6, and x equals 14. That would make the diagonals perpendicular. All right, questions? Okay. Homework. Number 8 through 18 even there. We also have our Common Core 13 and Algebra Review 17. That will be due on block day. And
Is this homework due on Tuesday?
this homework, the bookwork, is due on Tuesday. These two are due on block day. An entire week from now. All right.